Hello. Thanks for joining us today. I have your resume here, and I see you are a recent graduate. It is great to have some fresh energy and new perspectives in the team. To start off, why don't you tell me a bit about your journey with Flutter and what got you interested in it?
Hi, thank you so much for having me. I am really excited to be here. I actually stumbled upon Flutter during my final year of university while I was looking for a way to build a cross-platform app for my senior project. I had tried a bit of native development, but the idea of a single codebase for both iOS and Android was a huge draw for me. Once I started playing with the widgets and saw how fast I could iterate using hot reload, I was hooked. I spent most of my last semester diving deep into the documentation and building a few personal projects to understand how the framework actually handles things under the hood. Since I am just starting my professional career, I have spent a lot of time focusing on the theoretical foundations and the architecture, and I am eager to apply that in a real-world production environment.
That enthusiasm is exactly what we look for. Since you mentioned the fundamentals, let's jump right into the core of Flutter. Most beginners just call the build method and see something on the screen, but I want to see if you understand the machinery. Can you explain the build method mechanism in deep detail? What actually happens when that build function is called?
Right, so the build method is really the heart of how Flutter creates the UI, but there is a common misconception that it creates the visual element directly. In reality, when the build method is called, it does not actually create a visual element on the screen. Instead, it returns what I like to think of as a configuration blueprint, which is the widget. To understand what happens next, you have to look at Flutter's three-tree architecture: the widget tree, the element tree, and the RenderObject tree.
That is a good start. Could you elaborate on how those three trees interact during the build process?
Definitely. When a build is triggered, Flutter takes that new widget blueprint and compares it with the existing element in the element tree. This is the critical part. If the widget type and the key are the same, the element does not get destroyed. Instead, it just gets updated with the new configuration from the widget and then tells the corresponding render object to update its properties. This avoids the expensive process of recreating the entire UI. However, if the widget type has changed, the old element and its render object are completely destroyed, and a new subtree is built from scratch. This whole process of comparing and updating is called reconciliation. The actual heavy lifting, like calculating the size and painting pixels, happens in the RenderObject tree. The build method itself is designed to be a pure function, meaning it should only describe the UI based on the current state and avoid any expensive logic or side effects. That is how Flutter maintains a smooth 60 frames per second.
You mentioned that the build method describes the UI. This leads into a broader concept. What is the actual purpose of the build method in the context of the programming paradigm Flutter uses?
The build method is based on the concept of declarative programming. In a traditional imperative approach, you would give the computer a series of step-by-step commands, like saying move this button here or change this text to blue. But in Flutter, you describe what the UI should look like for a given state. You are essentially saying, given this state, this is the hierarchy of widgets that should be on the screen. Every time the state changes, Flutter calls the build method again to create a new description of the UI. The framework then figures out the most efficient way to update only the parts of the screen that actually changed, rather than redrawing everything.
Now, you mentioned the widget and element trees. I want to dig deeper into that separation. Why does Flutter even bother having separate widget and element classes? Wouldn't it be simpler to just have one?
It might seem simpler at first, but the separation is actually the secret to Flutter's performance. A widget is just a lightweight configuration. It is immutable and very cheap to create and destroy. On the other hand, an element is the actual living instance of that widget. While widgets are being destroyed and rebuilt constantly whenever a state change occurs, elements are persistent. The element acts as a manager that links the widget blueprint to the actual render object that draws on the screen. If the framework had to rebuild the entire rendering tree every time a single variable changed, the app would be incredibly slow because render objects are heavy. By using elements, Flutter can compare the new widget blueprint with the existing element and only update the specific properties of the render object that changed.
Speaking of things being immutable, you used that word a few times. Can you explain the concept of immutability in the context of Dart and Flutter?
Sure. Immutability means that once an object is created, its state cannot be changed. In Dart, we achieve this using the final keyword for variables and the const keyword for compile time constants. In Flutter, this is a core architectural decision. Because the UI is declarative, instead of modifying an existing widget to change what is on screen, Flutter destroys the old widget and creates a new one with the updated values. This sounds like it would be slow, but it is actually very efficient. Because the widgets are immutable, Flutter can quickly compare the old and new states to determine exactly which parts of the screen need to be repainted. It prevents a whole class of bugs caused by unpredictable state changes and makes the reconciliation process much faster.
Let's talk about a practical challenge. Imagine you have a complex list of widgets. If you are using a state management tool like Block or Provider, you might find that your widgets are rebuilding more often than necessary, even when the data hasn't changed. Why does this happen, and how would you use something like Equatable to solve it?
That happens because of how Dart handles object equality by default. In Dart, objects are compared by their identity, which means two different objects are considered different even if they have the exact same data, as long as they point to different memory addresses. So if your state management creates a new state object with the same values as the previous one, Flutter sees a new object and triggers a rebuild. This is where Equatable comes in. By using Equatable or writing custom equality checks, you can tell Flutter that two objects should be treated as equal if their internal properties are identical. This is necessary in complex lists to prevent unnecessary rebuilds, which not only improves performance but also prevents annoying UI glitches like flickering or the loss of scroll position when they state updates.
That makes sense. Now, moving toward the rendering side. Most of the time, built-in widgets like container or column are enough. But can you describe a scenario where you would need to use CustomPaint and the Canvas API?
I would use CustomPaint and Canvas when I need to draw complex shapes, custom animations, or high-performance graphics that simply cannot be achieved by nesting standard widgets. For example, if I wanted to create a custom circular progress indicator with a specific gradient, or a complex data visualization like a line chart with smooth Bezier curves, using standard widgets would be a nightmare. You would end up with a massive stack of containers and opacity widgets that would be hard to manage and inefficient. CustomPaint allows me to talk directly to the rendering engine, which reduces the overhead of creating hundreds of separate widget objects in the element tree. It gives me total control over every single pixel on the screen and is much more performant for non-standard geometry.
Let's shift gears to how the whole app actually runs. If you had to explain the Flutter rendering pipeline to someone, how would you describe it?
The rendering pipeline is the journey from the code we write to the pixels on the screen. It happens in 4 main stages. First is the build phase, where Flutter creates the widget tree. Second is the layout phase, where the framework calculates the size and position of every element. Third is the paint phase, where the framework records how the UI should look. Finally, there is the compositing phase, where those recordings are sent to the engine to be rendered by the GPU. What makes Flutter high performance is that it does not use native OEM widgets from the platform. Instead, it uses its own engine like Impeller or Skia to draw everything directly on a canvas. This bypasses the slow communication between the framework and the platform, which is why it can hit those high frame rates of 60 or 120 frames per second.
You mentioned the platform here. Since Flutter is a UI toolkit and not a native app in the traditional sense, how does it handle things that are strictly native, like checking the battery level or accessing a specific system sensor?
That is where platform channels come in. Since Flutter runs in its own engine, it cannot directly access native APIs written in Java, Kotlin, Swift, or Objective-C. A platform channel acts as a bridge. It uses a system called method channels where the Flutter side invokes a method by name and sends a message to the native side. The native side listens for that specific method name executes the required native code, and then sends a response back across the bridge to Dart. It is absolutely necessary whenever you need a feature that is not provided by a Flutter plugin or requires a specific system-level API that only the host OS provides.
Very good. Let's talk about development workflow. You've probably used hot reload and hot restart a lot. From a technical standpoint, what is the difference between the two, and when does the app state actually reset?
Hot Reload is designed for quick UI tweaks. It injects updated code into the running Dart virtual machine without changing the current state. So if I have a counter at 5 and I change the color of the text, the counter stays at 5 because the state is preserved. Hot Restart, on the other hand, is more aggressive. It destroys the current app state and restarts the app from the beginning. This resets all variables and takes you back to the initial screen. I use Hot Reload for the majority of my work, but I use Hot Restart when I change global variables, static fields, or the main function, because those changes require the app to be reinitialized.
Let's dive into some Dart-specific features. What is a Dart extension, and how could it actually make your code more readable in a project?
A Dart extension is a way to add new functionality to an existing class without having to modify the original class code or inherit from it. It is incredibly useful for classes that come from a third-party library or the built-in framework where you cannot change the source code. Instead of creating a separate utility class with static methods which can feel clunky, I can define an extension. This makes the new method look and feel like it belongs to the original class. For example, if I wanted a way to quickly capitalize the first letter of every string in my app, I could create a string extension. Then I can just call my string capitalize, instead of calling a utility method, which makes the code much cleaner and more intuitive to read.
I like that. Now let's talk about architecture. For a fresher, dependency injection can be a tricky concept. How does Flutter manage dependency injection in complex setups, and what patterns would you recommend?
Flutter does not have a built-in dependency injection framework, so we usually rely on third-party libraries or the inherited widget mechanism. In a complex setup, a very common approach is using a service locator like Getit. With Getit, you register objects as singletons and can access them from anywhere in the app without passing them through every single constructor. While it is very efficient, it can make testing harder because it creates a global state. An alternative pattern I prefer for larger apps is the provider or riverpod approach. Instead of a global locator, these tools inject dependencies from the top of the widget tree down to the children. This makes the data flow more predictable, makes mocking easier during tests, and automatically handles the lifecycle of the dependencies based on where the widgets are located in the tree.
Speaking of state management, let's talk about the simpler tools. When would you choose a value notifier over a standard change notifier?
I would use a value notifier when I only need to track and notify listeners about a single value of a specific type. It is essentially a specialized version of change notifier that simplifies the process because it handles the value storage and the notification logic automatically whenever that value changes. It is perfect for simple things like a toggle switch or a simple counter. However, I would use a standard change notifier when the state is more complex, like when I have multiple related variables, a list of data, or business logic that requires custom trigger points for updates. Change notifier gives me precise control over when the UI should rebuild, whereas value notifier is strictly tied to the change of a single value.
Let's move to navigation. In a real app, you can't just push a simple page. You often have to pass complex data and ensure the user can return to a specific state. What is the recommended way to handle this?
For complex navigation, the recommended approach is using named routes combined with a dedicated state management solution or a routing library like GoRouter. Instead of passing a large, complex data object directly through the constructor of a widget, which can be messy, I would pass a unique identifier like an ID in the route parameters. Then the receiving page uses that ID to fetch the required data from a shared state manager, a repository, or a local database. To ensure the user can return to a specific state, I can use the navigator's pop method to return a result to the previous screen, or simply maintain the app state in a global provider so that the Data persists even after the user navigates away and comes back.
Imagine you are working on a feature that requires a list containing different types of items, like an image card, a text card, and maybe a video card. How would you manage this variance in a list view?
The best way to handle that is to use a list view builder and implement a conditional statement or a switch case inside the item builder. Since there is no single widget that automatically handles different types, the builder allows me to check the type of the data object for the specific index. If the data is an image object, the switch case returns an image card widget. If it is a text object, it returns a text card. This keeps the logic clean and allows each item type to have its own dedicated widget for styling and behavior.
Now let's talk about optimization. If you were handed a project with a very complex widget tree and it was lagging, how would you approach optimizing it?
My main goal would be to reduce the number of widgets that need to rebuild during a state change. First, I would look for any widgets that never change and give them const constructors. This tells Flutter to reuse the existing element instead of recreating it. Second, I would move state management closer to where it is actually needed. Instead of rebuilding the whole screen, I would use localized state management or widgets like Value Listenable Builder so that only the small piece of the UI that depends on that data gets updated. I would also make sure there is no expensive logic or calculations inside the build method. Finally, if there is a particularly complex part of the UI that updates frequently, I would wrap it in a repaint boundary to isolate it from the rest of the screen, which prevents the entire screen from repainting.
You've mentioned the main function before. Just to be thorough, can you explain the purpose of the main function in a Flutter app?
The main function is the absolute entry point for every Flutter application. When the app is launched, the operating system looks for this specific function to begin executing the code. Its primary purpose is to initialize the app and trigger the runapp function. The runapp function is what actually attaches the root widget to the screen and starts the entire Flutter framework's rendering process. Without the main function, the engine would have no starting point to launch the UI.
Last technical question for you. Since you are a fresher, you'll be doing a lot of data integration. How do you typically make an API call in Flutter?
To make an API call, I typically use the HTTP package. The process involves importing the package and creating a function that returns a future, since network requests are asynchronous. I use the async and await keywords to ensure the app doesn't freeze while waiting for the server. I would send a GET or POST request to the URL, and once the server responds, I check the status code to make sure it was successful. Then I use the Dart convert package to transform the raw JSON string from the server into a map, or preferably a custom Dart object using a model class, which then allows the UI to display the data easily.
I've been very impressed with your depth of knowledge. Even though you don't have years of industry experience, your understanding of the underlying architecture, like the three-tree system and the rendering pipeline, is very solid. Do you have any questions for me about the team or the projects you would be working on?
Thank you so much. I really appreciate that. I actually do have a question. Since I am coming in as a fresher, I am very eager to learn the professional standards for code reviews and testing. Does the team use a specific methodology for testing, like unit tests or integration tests? And is there a mentorship process for new developers to get up to speed with the codebase?
That is a great question. We actually place a huge emphasis on testing. We use a combination of unit tests for business logic and integration tests for the critical user flows. We also have a very strong peer review culture, where every pull request is reviewed by at least 2 other developers. For new hires, we assign a dedicated mentor for the first 3 months to help you navigate the architecture and get comfortable with our specific patterns. We believe in growing our developers, so you will have plenty of support.
That sounds like exactly the environment I am looking for. I really value mentorship and the opportunity to learn the right way to build scalable apps.
It sounds like you'll fit in well. Thank you for your time today. We will be in touch very soon regarding the next steps.
Thank you again. I look forward to hearing from you. Have a great day.